Testing, testing. 1, 2, 3. Well, hello everyone. We're now dealing with our third section. This one's going to be relatively quick because the questions are very straightforward. What is the maximum or minimum value of a quadratic when it's written in its general form? So if you have a quadratic that's written in this format, it can only be one or the other, right? If it looks like that, it's going to have a minimum value, which is the y value here. If it's written, it looks like that, it's going to have a maximum value. So here's our first thing. If a is greater than 0, which means it's that shape, it has a minimum value. The minimum value will be the y-coordinate of the vertex. If a is negative, which means it's that shape, it's going to have a maximum value, and that will be equal to the y-coordinate of the vertex. So for these questions, all you really need to know is what's the y-coordinate of the vertex, and is it a max or a min? And we could certainly do it. It would take a bit longer. I could just take the general form, right, that they give us, like this guy, and then reduce it into its standard form, and then find the vertex, and then from there get the answer. But we can actually short circuit that and do it a little bit quicker. So how are we going to do that shortcut? We're going to use this property. The x coordinate of the vertex is negative b over 2a. And we're going to use that and evaluate the quadratic at this point. And when we evaluate the quadratic, we're going to find the y-coordinate at that point, and that's going to be our max or min. That's pretty much it. So let's jump right into an example. 3x squared plus 12x minus 2. First, I know that a is 3, which means it's greater than 0, which means it's that shape, which means I now know it's going to be a minimum. Right? Minimum. That's the smallest the y value ever gets. Now the x coordinate is negative b over 2a, which is negative 12 over 6, which is negative 2. The y-coordinate of the vertex will simply then just be the value of the function, right, at negative 2. So 3 lots of negative 2 squared plus 12 lots of negative 2, take away 2. That's 4. 3 lots of 4 are 12. That's take away 24, take away 2. The answer I get is negative 14. So I can now say that it has a minimum value and it's equal to negative 14. So essentially, we're just finding the y-coordinate of the vertex, and that will tell me the maximum or minimum value, depending on the shape. Now, that means you can do it with anything, no matter how ugly it is. That's pretty ugly, and I'm sure I'm going to get really ugly answers out of it. But a is negative 4, b is 7. I don't really care about c, it doesn't. It's not involved in this part. The x-coordinate of the vertex is that negative 7 over negative 8, so it's basically 7/8. And then the y value then is this guy when x is 7/8. Oops. And I've had my calculator here, which is what you really should do. Oh, wait a minute, I can actually do that. If you hold on for a few seconds, That will show you how you can deal with ugly questions, ugly values. Here we go. So I'm going to, as I find this right button to press. So I need to do -4 times 7/8 squared. So that's how you get -4 times 7/8 squared. I'm then going to add 7 times 7/8. And then I'm going to add 11. And when I hit enter, a horrible decimal will appear. There we go. But I don't want decimals. I want exact values as fractions. So you hit the math button. And you use this interesting option number 1, which basically says take the answer and make it a fraction. And when you hit enter, 225/16. So I now know the y-coordinate of the vertex. Now we already know that this has a -a, and don't negative a's look like that, right? They open downwards. So this guy is a maximum value, and it's 225/16. Now someone might say to you, oh, what's the domain of that function? Well, it's that guy or anything below. -infinity up to that guy, the maximum value, square bracket. If I asked you for its range, which is a bit of a silly question, because it's everybody. Slightly different question. Let me show you this homework question. So we've covered all the possibilities. They've given you the quadratic, right? So you're basically just going to read off the answer. So that's 1, 2, 3, 5. So that's 1, -5. The x-intercepts. Oh, I can't read off very accurately the x-intercepts here, right? So what I suggest you would do then is use the quadratic formula. And I'm pretty sure that's why they say round off to 1 decimal place. Now, if you want to find the x-intercepts, then you're going to have to solve when is this equal to 0. So you're going to have to use the x equals -b plus or minus the square root of b squared minus 4ac all over 2a. We call that the quadratic formula. And I have no idea what the answer is, so I'm just pretending I do. 0.1, -0.1, and 1.9. You'll find out, yourself. Now find the maximum or minimum value. It's quite clearly that this function is a minimum value, and it's 1, 2, 3, 4, 5. So it's, let's do its y-intercept first. That's easy to do, -1. So 0, -1. Now that shape is a minimum, so you choose minimum. And I think I can read that off as 1, 2, 5, 1, 5, yeah. So -5. The domain of this function is easy. It's -infinity plus infinity, because it's everybody. And the range of this function, well, we know that that number is the lowest, and the y value is the range, or the y values is everything above that. So square bracket, -5 to infinity. Right, now I'm pretty comfortable with the answers except the X and Y intercept. So another thing I just noticed, that it's coordinates. So let's put those in as well. Let's see how good I am at guessing X intercepts. Okay, I got lucky. It is actually 0.1 and 0.9. And that is the end of that section.